Hello, dear subscribers. Today we are going to uh, look at something one of our listeners asked for, a certain Tam from the Pixie asked how to extract a certain parameter from a certain region of space. And here we're going to do just that. So what we're going to do is first consider a point that stays in the same position in time, and then a point that's moving in time. For example, if you want to do an insertion problem, you can see the laws acting 1 meter away from the pile as the pile gets inserted. So let's start. In this case, what this individual wanted is the PQ, or stress invariance plot, at a certain distance from the pile. So we have the code from last time. I'm just gonna copy this as example 2. If you look at the results here, you have the stress invariant Q and theta, which is n by 2 matrix, since n is number of elements and 2 is the value, not theta. Uh, we don't care about theta. N and P and Q, not theta. So since in this, you can see here the results, in this maybe stress invariance muted P, okay, you can see here that we don't really care whether this, we could just take all the data just from the intertrock, but since unless we consider a point very close to the pile, we can just say we don't care which portion of the geometry this is part of. I'm gonna consider, for example, diameter divided by 1/10 of the diameter and extract the data in this position. So let's say this is the same velocity displacement as last time. Distance is distance or position, initial position is equal to diameter divided by 2 plus diameter divided by 10. Since this is center, so geometry, I don't remember properties, so geometry distance, this is 0.5 roughly, 0.5 meters diameter. So let's just say that we're gonna go 25 centimeters from the pile center plus 5 centimeter. So diameter is 50 centimeters. The initial position is this one. So my position, I don't care about the contact force anymore. I need the okay, there is a boar coming up to the place. I'm gonna pause a second. Well, after some individuals without a PhD tried to insult me, we are going back to the video. So I'm getting the stress invariant Q and the stress invariant P here. So ID is 1 and the value, since it's n by 2 matrix. I don't care about getting the elements. What I care about is finding the position of the point where we're trying to sample, which is equal to my position is equal to initial position plus uh, my results dot time, no, or steps, or even I don't need to do that. I already have displacement plus displacement and just current step. So we have my position. We know from the recording, yes, from the results that on the x-axis it's just at 0. So my position is equal to 0, and the y is initial plus displacement. And we also have all the mesh or triangles. We know that the Q is a nodal element result, so it turns out we do need to use the mesh. We know that it's in the first mesh because it's the bigger one, which is the intact rock, and we know what all these things are, or the node ID, which are associated to a certain node. So what we need to do first of all is calculate the position of each element, because we only have the connectivity matrix, but it does not give us the position per se. So first of all, maybe just, nope. Okay. I'm just gonna copy this from last time. Um, my elements are first mesh in the current step. We don't need to do reshaping because we care about each of the three element positions. So what we do is, it's probably possible to do it without a loop, which is more efficient, but I think this is more clear for L index is equal to from 1 to length my elements.
Oh my god!
Thank you. Okay, after some certain animal that is not even subscribed interrupted me. So what we're going to do now is cycle for each element of this area, which my elements is n by 6 uh, results. So ID x y or node 1 2 3 4 1 2 3. I don't know what this is. I don't know what this is. Uh, so what we need to do is find the position of a given element, and the way we're doing this is my position or my uh, individual element is equal to my elements element index. Oh, let's call this my nodes. And from 2 to 4, if I remember. Yeah, 2 to 4. And then from the node matrix, I get my positions, which is equal to element uh, my nodes. Let's say element index equal 1, so my nodes is equal to these three nodes. So we're just flipping this or transposing this so it's vector, and then from the node matrix we're getting the second and the third row or column, because the third one is just 0 because it's a 2D model, and the first one is the D. Should be linearly increasing, yeah. So 2 and 3, and these are my the position x y of the three nodes I'm this element is made of. And so we can just do my pos, which is the mean, so the center of the element, or my pos radius, and 1 because we want vertical sum, and this is this correct? I think it is. Yeah, this is the average. So this is the center of the element, and what we can do is just assign my element in element index. So 5 and 6, which we are not using anyway because I don't know what these are, we can assign them here. The position of the element is equal to my position. So I'm just going to run this real quick, and this will give us, well, if this runs, for each element we have a D, node 1, 2, 3, and X, Y of the center of the element. Okay. Next thing we can do is verify that what we got is correct. So what I'm going to do is just do a scatter plot, and what we're going to plot is my elements and type, yes, X, Y, and then, for example, I want the Q value or the P value. Where do I want it? In for the elements of the given ID, so the first column, and this should give me the scatter plot of the P, which I've never calculated. So let's see if this loads. I'm gonna pause. Okay, so I've modified the code a bit. It's still scatter with element X, Y. I'm adding an empty input or empty argument to the function because this I think is the X or the Z position which we don't have, and then the value of the element is, or value on the point is put afterwards. It's not just P my element because in this case it will just give me the first row, so I need to specify the second row, which is the value, and then I'm specifying that I want the scatter to be outputted as a point and not as a circle, and this is the result. So you can see that. Let's zoom in. These are the value of P, I think, in the entire domain, and so yeah, P and the same with Q. So what we're going to do now is find a way to extract this value at the position of the of interest, which is my pos. And since this is scattered data, what we're going to do is use a scattered interpolant to, well, calculate it. So the command is just scattered interpolant, and P is the position, in which case is my element X and Y, X, Y, V, which is the value, so this one. Then it says method, the default is linear, we're gonna just write linear, and then extrapolation method. In this case it doesn't really matter because we're getting a value to the center. Let's just say we don't want any extrapolation. So this is the scatter interpolant for P. We're gonna do the same with Q. This is the same. Well, oopsie. And then my P is equal to scattered interpolant P in the position my pos and your pos. And then do the same with Q, and I should have two values. Yeah, P negative is because it's compression, it's negative forces, and so I can just put them in a matrix of result, mat PQ at the time step, uh, two columns is equal to my P and my Q. I don't care about the forces anymore, I can just delete this, close all, and I can plot P against Q as a certain animal was asking earlier on, and I'm plotting these as points because it's probably gonna scatter around a bit. And I'm gonna press play and pause. So this is the result. Let's just do X label P. This should be KPA. I can type. And the same for Y, Q. I don't know how readable this is. Let's just also do something like figure Y axis. Not even that. Let's just do plot displacements. Mat PQ1 display name P. Also, let's do a negative sign, so it's all same sign, and the same with Q. Hold on, Q legend. Very useful. Well, hey, not my call. Then this is what you got. Which makes sense. It's so spiky because if you see, for example, here P or same for Q, it's basically waves. So one thing we could do is instead of considering my position as a changing value, we can just consider a static position. So instead of doing d2 plus d divided by 10, we can do the third, so roughly here, I guess, and see how, consider a static point, this value changes. I'm just gonna run this again and pause because its computer is dying. Oops, dying. Well, unfortunately, the result is very similar. Well, it is what it is. My pause. No. Oh, because I'm in pause. Because I'm updating it with the last position of the nodes, so this is why it's so weird. Let's just do this again. While the code is running, I'm just creating this initial position, which is static, and displace initial position. Uh, minus t bench. Yeah, this is better. This is with a constant position, and gonna do the same with the initial position too. So I'm just gonna copy all this down here, call it 2, P2, 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 and just changing using initial position too, and this should copy this, and just do the same with 2. Let's see how it goes. I'm gonna pause for a second because people are messaging me. Okay, so this is the result now, where the one on the left, 1 and 2 are at a constant position in space, and you can see some sort of waviness in the PQ values, while the one on the right, I don't know how to interpret this on top right, but this is at a constant distance from the pile, and you can see it's, well, less wavy, I guess. And also, this massive spike is probably due to the mesh not being very thin in this period of time. But yeah, this is about it. See you next time. Dun-dun-dun. I really want to put some transition music like a real YouTuber.